Just a quick video here about something that drove me crazy. I used my Rig Expert antenna analyzer to make some measurements on antenna system, and it was throwing me weird numbers, and then I finally just checked it against my dummy load with a high quality cable that I thought, and I was using the dummy loads in the past, and something isn't right. It's showing SWR of infinite. Definitely that had me change the cable a couple times to see what the issue is, and just couldn't figure it out, and I was starting to worry that the antenna analyzer is bad. So I've been trying out things, and this thing was, when I was trying out, okay, I'm giving it a little bit away here. The issue was I was like taking a different dummy load. It's like this one here, connected right to the SWR meter, and it's still the high infinite. So I found out about one of the features to do a system check is the SWR bridge. So if you go into settings all the way to page 3, there's a resistive bridge levels. So we press 2 here, and now we can see we don't have any load on. So with no load, it should be in this red range for the bar 1, and for the bar 2, it should be in the middle range. If we have a 50 ohm resistant load, then it's a green. So if you see the green line down here, in both cases it's in the middle. So it should be in the middle. So if you take the resistor on it, and we see nothing happens. And that had me puzzled. And finally, I came on the idea to put a different connector on. Again, no load on there, so that's fine. We put the resistor on, and that's exactly what we should be seeing. Should be seeing the 2 bars drop down to the middle. So that connector is fine. Oh, and yeah, if we go now to the SWR measurement, yeah, we have a decent SWR, what we're expecting. So that connector is fine. Let's grab another connector and go over to settings, resistive bridge levels, and this one is working fine too. So if we look at these 2 connectors, they look just perfectly fine, both of them. And again, this one was the one that works. So let's find the one that doesn't work. Move that over here. So this one doesn't work. Let's double check that. So that doesn't work. It behaves like it doesn't have any connection through it. But if I go ahead and use the ohm meter on continuing mode, PP node. So right there we can put it on the shield and the center pin and no sound. That's good. If you put it on the shield, we hear the sound. So the shield works. If you put it right here in the center pin and out of the center, we hear it beeps. We can put on the 50 ohm connector and switch over to resistant measurements. So I'm going to the pin, and right here it says, don't move, 50.4 ohms. So that's just fine. So it's not totally sure why this connector doesn't work, but it's kind of concerning about using that connector in any kind of an antenna system. That one right next to it works fine. So we have two more of these. Let's check them out. I mean, the build is nice, sturdy and heavy. That one also didn't work. Let's go ahead with this one. That one works. So out of the 4 that we have, 2 work, 2 don't work. And there's just nothing that I can tell to separate them besides doing the SWR test. Because the ones that don't work have an infinite SWR. Let's go ahead and find again one of them. Is that the one that doesn't work? Yep. So let's go to the SWR measurement across the band. And let's pick all and run through the whole. There's like a no dip. So if you want to go to the 70 centimeters, that's where it dipped most. Definitely not impressive at all. So I don't know what to think about that. I can check this one. It's another one of a different style. And well, now we are much higher frequency. Let's go down to 7 megahertz again. There, that's just fine. If you go back to the settings, we see that as well. Shift bridge right there. It's within the expected range. So if you know what's going on with these connectors, I would be happy to hear about that. Another thing that I just wanted to point out is right here, the rig expert, to compare this here to how it works. I'm definitely no expert, but right there is the resistive bridge where we connect the antenna to. And then there are the two pulses, a switch and a mixer, and it does all that cool stuff, which we don't care about right now. We want to look at the resistive bridge. Oh boy. And that's right here. So we have the two signals, the one coming here and the one going directly into the mixer. So we are just interested in the channel 1, and the resistive bridge is right here. So one side always has 50 ohms and 50 ohms, and getting the signal right in half of the 50 ohms. The one leg is grounded, the other leg is at the signal, while from the antenna, so here the coax is, the shield is grounded, and the input comes in at the middle of the 50 ohms. And right there is the switch. I think for my little not knowing much, this is kind of to compare that side to this side also. Not totally 100% sure, but right here, that would kind of correspond to this here. So this leg, I assume, is that leg, this side, while this leg is that side of this, the resistive bridge. So that was kind of interesting to see the block diagram along with the testing function here. Of course, the schematics of the whole rig expert would be interesting too, but I haven't been able to find that. That's probably not out there for the curiosity person to look at. But anyway, if you have any clue why some of these connectors totally work fine on DC, but have a tremendous amount of SWR, that they don't work. Thinking of that, we probably should test them out at a low frequency. Let's try this here for a sec. Let me hook that up. Okay. I was lucky or unlucky and got the one that's broken. So let's go ahead and go and exit out of here. Do an SWR measurement all the way. Let's just do 160 for right now. I don't think that's low enough. So let's go down to frequency 500 kilohertz and the range plus or minus 800, and see what's gonna happen here. Yeah, that one does not show at all any low SWR. If you go ahead and look at the data at 500 Hertz, see here resistive ohms of 5,000 ohms. That's way higher than it ought to be. And if you go ahead and change the frequency to, I don't know what's the lowest one, 100. Okay, that's the lowest here. So it's 5,000 ohms still. But if you go ahead and take this out and use the ohm meter, and do the measurement, which I can do with one hand. Hold on. I need to fix this here. All right there. Okay. So I put that on the shield and this at the center pin, and what we get is 50 ohms. You tell me what's going on here. I don't have a clue.